Hello students, welcome back to your one and only favorite YouTube channel, Tamasang Tutorial. Myself Kishan Kulung, and today we are ready to discuss about the modern periodic table, okay? The long form of periodic table. Henry Moseley, an English scientist with the help of other scientists like Niels Bohr and Werner, put forward his modern periodic law in the year 1911. And on the basis of his law, he designed a modern periodic table which we use today. So let's read out his law and then begin. Modern periodic law. The properties of elements are the periodic function of their atomic number. Let's understand this law first and then we will draw his modern periodic table as well, okay? The properties of elements means both the physical and chemical properties of elements are the periodic function means which reoccur after fixed interval, okay? Of their atomic number means when the elements are arranged in the increasing order of their atomic number. Let's understand this again. Henry Moseley arranged the elements in the increasing order of their atomic number. When the elements are arranged in the increasing order of their atomic number, the elements having similar physical and chemical properties reoccurred after fixed interval, okay? The elements when arranged in the increasing order of the atomic numbers, elements having similar physical and chemical properties reoccurred after a fixed interval, or you can say the elements having similar physical and chemical properties fall under the same group, okay? Now let's draw his modern periodic table and then we will understand better. Let's begin. The modern periodic table contains 18 vertical columns called groups and 7 horizontal rows called periods, okay? Now let me draw. The modern periodic table has 18 vertical columns called groups, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And 7 horizontal rows called periods. 1, period 2, period 3, period 4, period 5, period 6, and period 7. Okay? The modern periodic table has 18 vertical columns called groups. 1, 2, 3, 4, 5, 6, 7 up to 18 vertical columns called groups and 7 horizontal rows called periods. Okay, these are called periods. This is period 1, this is period 2, this is period 3, period 4, period 5, period 6 and period 7. Henry Moseley arranged elements in the increasing order of their atomic numbers, isn't it? So let's write the elements in the increasing order of the atomic numbers, okay? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. Up to class 10, this much elements is enough, okay? We don't need to learn all the elements. If you learn up to 20, then it is enough. So this is hydrogen having atomic number 1, helium atomic number 2, lithium atomic number 3, beryllium atomic number 4, boron 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and this is 20, okay? 19 and this is 20. Let me write 20, yeah, 20. Okay, and let me complete this. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, and beryllium, magnesium, calcium, strontium, barium, radium. Okay, this is group 1, this is group 2, this is group 3, group 4, 5, 6, 7, 8, 9, 10, 11, 12, and this is 13, this is 13, 14, 15, 16, 17, and this is 18. Okay, now the element in group 3, period 6, here we have element having atomic number 57 called lanthanum. Okay, and after that element having atomic number 58, atomic number 59, atomic number 60. All these elements have similar properties to the elements of group 3. Okay, but these elements could not be written here because this would have extended the periodic table, isn't it? So to avoid the extension of group 3, these elements are written separately here, making the separate column. Okay, now this is element having atomic number 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, and 71. Okay, there are 14 elements here. 14 elements here, and in same group but in seventh period we have another element named actinium having atomic number 89. Okay, 89. After that the elements having atomic number 90, 91, 92, they also have the similar properties to the elements of group 3. So to avoid the extension of group 3, these elements are written in the separate column here. 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, and 103. Okay, so this period also contains 14 elements. Okay, now elements of group 1 and 2. This group 1 and 2, you can see this is a block, isn't it? This is a separate block. So this block is called S block. S block. S block. And this block 13, 14, 15, 16, 17, 18, this block is called P block. Okay, P block. P block. And from group 3 to group 12 are called D block. D block. Are you getting me? This S, P, D are the subshells. From the subshells of shells, we have this S, P, D, and F. This is called F block. I will explain that in the later video. F block. Okay. Now, group 1 and 2 are called S block. Group 13 to group 18 are called P block, and group 3 to group 12 are called D block, and these elements are from group 3 only, and these are called F block. And F block contains 14 elements in each group, and the series are called elements of this series are called Lanthanide series, Lanthanide, Lanthanide series. And the elements of this series are called Actinide series. Okay, Actinide series. I hope you got this. Now let's understand further. We don't need this now, So I'm erasing it. So S block elements, S block, group 1 are called alkali metals. We must remember this. Group 1 are called, elements of group 1 are called alkali metals. Okay, alkali metals. Alkali metals. And elements of group 2 are called alkaline earth metals. Alkaline earth metals. Elements of group 1 are called alkali metals, and elements of group 2 are called alkaline earth metals. Both fall in group 1. S block. Okay. Now P block. Let me erase this. P block elements. P block. Group 13. Group 13 are called boron family. Boron family. Group 14 are called carbon family. Okay, carbon family. Group 13 are called boron family. Group 14 are called carbon family. Group 15 are called nitrogen family. Nitrogen family, or they are also called pnictogens. Okay, they have a special name called pnictogens. And group 16 are called oxygen family. Oxygen family. They are also called chalcogens. Okay. And group 17 are called fluorine family. And they are also called halogens. Okay, they are the most electronegative elements. Okay, group 13 elements of group 13, they all belong to P block. Okay, P block elements. Group 13 are called boron family. Group 14 are called carbon family. Group 15 are called nitrogen family, or nitrogen family have a special name called pnictogens. And group 15 are called group 16 are called oxygen family. They are called chalcogens. And group 17 are called fluorine family, and they are also called halogens. Okay. Now group 18 are called noble gas. Noble gas, or you can also say inert gas. Why they are called inert gas? Because they have stable electronic configuration and they do not react with any other element. They have zero valency, so they are also called zero valent elements. Okay, they are called zero valent elements. Zeroth group also. They are also called zero valent elements because they do not react with any other elements. They are the most unreactive elements. Okay, so they are called noble gases or the inert gases. Okay. Now let us see the number of elements in each period. Okay, number of elements in each period. Period 1, we have only 1 and this 2, isn't it? In period 1 we have 1 and this 2. Two elements, hydrogen and helium, isn't it? To write this, you need to remember this magic number 2, 8, 8, 18, 18, 32. Okay, 2, 8, 8, 18, 18, 32. We must remember this number, then it becomes very easy for us to remember the number of elements in each period. Okay, period 1 contains hydrogen and helium, that is 2 elements, and period 2 contains lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, isn't it? 8 elements. Period 4, this is period 1. Period 1. This is period 2. This is period 3. Period 3 contains 8 elements. 1, 2, 3, 4, 5, 6, 7, 8, isn't it? 8 elements. Period 4. Now 2, 8, 8, 18, isn't it? 18 elements. Period 5 also contains 18 elements, because we have 18 here elements. Period 6 contains 32 elements, and period 7 also contains 32 elements, and period 7 is incomplete. Okay, period 7 is incomplete because the new elements which are being discovered are kept in period 7. Okay, we must remember this magic number 2, 8, 8, 18, 18, 32, 32. We have more 32 here, 32. If you remember this, period 1 contains 2 elements, period 2 contains 8 elements, period 3 contains 8 elements, period 4 18, 18, 32, 32. Now period 1 is called the shortest period because it only contains 2 elements. Period 2 and period 3 are called short period because both of them contain 8 elements in each period, isn't it? And period 4 and period 5 are called long periods because both these periods contain 18 elements in each period, and period 6 and 7 are called very long periods. Okay, period 6 and period 7 are called very long periods, and period 7 is incomplete period. Okay, now let us see the groups from this periodic table. Let us understand something from the groups as well. Now we know the atomic number of hydrogen is 1, atomic number of lithium is 3, isn't it? Now the same rule applies. 2, 8, 8, 18, 18, 32. Okay, atomic number of lithium is 1 plus 2 is 3, isn't it? Now 3 plus 8 is 11, 11 plus 8 is 19, and 19 plus 18 will be the atomic number of rubidium. 19 plus 18 is 37, isn't it? 19 plus 18 is 37, that will be the atomic number of rubidium. Now again comes 18, 37 plus 18 is 55, that will be the atomic number of cesium. Now 55 plus 32, isn't it? 55 plus 32. 55 plus 32. 7, 8. 87 will be the atomic number of francium. We can determine the atomic number also from this magical number. Okay, so this magical number is very, very important. Here let's check this also. The atomic number of beryllium is 4. The atomic number of magnesium is 4 plus 8. 12. 12 plus 8 is 20. 20 plus 18 will be 38, isn't it? 38 38 plus 18, isn't it? 38 plus 18 is 16, 3, 4, 5. 56. Barium, 56 plus 32. 88 will be the atomic number of radium. 87, 88, 89, isn't it? These are arranged in the increasing order of the atomic numbers. So from this magical number we can determine the atomic numbers of the elements as well, and we can know the number of elements in each period, isn't it? I hope you got this. Now let's talk about groups, okay? Let's talk about group 1. Group 1, significance of group 1, okay? Let us see the electronic configuration. Hydrogen, atomic number 1. So electronic configuration will be 1. Only one electron in the outermost orbit, isn't it? So second is lithium, atomic number 3. 3 means in the first orbit 2 electron, in the second orbit 1 electron. Third is sodium, atomic number 11, isn't it? Atomic number 11. 11 means this is 3, this is 11. 11 means 2 plus 8 plus 10. 10 plus 1 is 11. Similarly, potassium, atomic number 19. Atomic number 19. 2 plus 8, 10. 10 plus 8, 18 plus 1, 19. That means elements of group 1 has 1 electron in the outermost orbit, isn't it? So let us say group 2. Group 2, atomic number of beryllium is 2, isn't it? So the electronic configuration will be 2. 2 electrons will be placed in the first orbit. So atomic number of magnesium is 12, isn't it? So electron will be placed 2, 8, 10, 10 plus 2, 12. 2 plus 8, 10, 10 plus 2, 12. Atomic number means the number of protons inside the nucleus. And the number of protons will be number of electrons, isn't it? Because the atoms as a whole is neutral. To become neutral, number of protons and number of electrons should be equal. So the atomic number of magnesium 12 means the number of electrons should be 12 outside the nucleus. So the electrons will be distributed in the orbits like this, 2, 8, 2. By the rule 2n square, okay? I hope you know this. And similarly, calcium, atomic number 20, isn't it? 2, 8, 10, 10, 8, 18, 2. So in group 2 we saw the outermost orbit contains 2 electrons. So if the atom contains 1 electron in the outermost orbit, then we can say that atom or that element is from group 1. And if the electron in the outermost orbit is 2, then we can say that element is from the group 2, okay? I hope you got this. Now let us check group 13, group 14, okay? Group 13, boron, atomic number 5, isn't it? Boron, atomic number 5. So 2, 5 means 2, 3. Aluminium, atomic number 13, isn't it? 2, 8, 3. 2, 8, 10, 10 plus 3 is 13. Now group 14, okay? Group 14. Group 14, carbon. Sorry, atomic number 6, isn't it? Group 14, carbon, atomic number 6. 2, 4. Carbon, after that comes silicon. Atomic number 14. 2, 8, 10, 10, 4. So 15, let's check group 15 also. Group 15, nitrogen, atomic number 7, isn't it? So 2, 5. Phosphorus, atomic number 15. 2, atomic number 15 means 2, 8, 10, 10, 5, 15. Number of electrons in the outermost orbit is 5. So here we can see, if the number of elements in the outermost orbit is 3, then it belongs to group 13. If the number of electrons in the outermost orbit is 4, then that atom belongs to group 14, that element belongs to group 14. And if the number of electrons in the outermost orbit is 5, that atom is from group 15, isn't it? So the similar goes to group 16 and group 17 also. So from here we can say that if the electron in the outermost orbit of atom is one, if the electron in the outermost orbit of atom is 1, then the element is from group 1, isn't it? Group 1 we have seen here. Similarly, if the electron in the outermost orbit is 2, then the element is from group 2, isn't it? So if the electron in the outermost orbit is 3, then comes 3 plus 10. Okay, we must add 10. After 1 and 2, group 1 and 2 remain same. But if you come to 3, 4, 5, then you have to add 10. If the electron in the outermost orbit of if the electron in the outermost orbit of the atom is 3, then the element is from group 3 plus 10. Okay, 3 plus 10, that is from group 13. Are you getting me? If the electron in the outermost orbit of the atom is 5, then the element is from group 5 plus 10 is 15, isn't it? Here we saw the electron in the outermost orbit is 5, so 5 plus 10 is 15. I hope we got this. Depending upon the number of electrons, we can say from which group does the element belong. Okay. Now let's check the period also. Period 1. Okay. Period 1, we have hydrogen and helium, isn't it? Period 1. Hydrogen, atomic number 1, so the number of electrons in the first orbit will be 1. Helium, atomic number 2, isn't it? Helium, atomic number 2, so the maximum number of electrons the first orbit can hold is 2, isn't it? So 2. Second period, period 2, let's check second period, period 2. We have lithium, beryllium, isn't it? Lithium, atomic number 3, so 2 electrons in the first orbit and 1 electron in the second orbit. Beryllium, atomic number 4, so we have 2 electrons in the first orbit and 2 electrons in the second orbit. Similarly, period 3, sodium and magnesium. Sodium, atomic number 11, means 2, 8, 1. 2 electrons in the first orbit, 8 electrons in the second orbit, 10. 10 plus 1 is 11. Sodium, then comes magnesium, atomic number 12. So 2, 8, 2. Period 4. Okay. Period 4. Are you getting me? Period 4. Let's check the element potassium and calcium. Potassium, atomic number 19. You can check the elements from here also, okay? Atomic number 19, 2, 8, 8, 1, isn't it? 2, 8, 10, 10 plus 8, 18, 18 plus 1, 19. And potassium and calcium, isn't it? So calcium is atomic number 20, 2, 8, 10, 8, 18, 2, 20. So first period only one cell, isn't it? One cell. Period 2 means one cell, two cell, one cell, two cell. Period 3 means 1, 2 and 3 shells, 1, 2, 3 shells. Period 4 means 1, 2, 3, 4 shells, 1, 2, 3, 4 shells. Similarly, if you go to period 5, 6, 7, the number of electrons distributed will be in the similar ways, okay? Number of period will determine the number of shells in which the electrons are distributed, okay? I hope you got this. Now, let us check one question, okay? Determine to which group and period the following elements belong. Elements having determine to which group and period the following elements belong. Okay, belong. Atomic numbers are given. So atomic number 1 is 20, number 2 is 14. Okay, number 3 is, okay, let's say 9. To which group and to which period? Okay, 20 means, let us write the electronic configuration. 2, 8, 2, 8, 10, 8, 18, 2, isn't it? 2, 8, 18, 8. 2, 8, 10, 10, 8 is 18, 18, 2 is 20, isn't it? 2, 8, 10, 10 plus 8, 18, 18 plus 2, 20. So the outermost orbit contains 2 electrons, means this element belongs to group 2, isn't it? In group 2. Determine to which group and period. Now comes the period. Which period? 1, 2, 3, 4. Period 4. Are you getting me? So this element belongs to period 4. Means group 2, period 4. 1, 2, sorry, 1. This is period 1. 1, 2, 3, 4. This is calcium, isn't it? This is calcium, okay? Now let's check out this. 14. 2, 8, 10, 10, 4, 14, isn't it? So the outermost electron contains 4 electrons. 4 means 1 and 2 will be the group 1 and 2. So if the number is more than 2, that is 3, 4, 5, then we have to add 10, isn't it? So 4 plus 10 is 14. This means this element belongs to group 14. Group 10 plus 4, 14. Group 14, okay? Group 14. Now, period, which period? Period is 1, 2, 3, isn't it? Period is 3. So period 3, group 14. Period 3, group 14. Group 14 means this. Period 3 means first period, second period, and third period. Silicon, isn't it? So now comes atomic number 9. Atomic number 9. Element having atomic number belongs to which group and to which period? Okay, to which group and to which period? Atomic electronic configuration is 2, 8. The maximum number of electrons that can be accommodated in the first orbit is 2, and in the second orbit is 8. Okay, but we have only 9 electrons, so 2, 8 will become 10. So we must write 2 comma 7, isn't it? The second orbit can hold 8 electrons, but we have only 7 electrons left. 2 plus 7 is 9. So the outermost orbit contains 7 electrons, which means 7 electrons means 10 plus 7, that is 17th group, isn't it? Group is 10 plus 7, that is 17th group. 17th group is this one. Okay, now let's check out period. Period is 1, 2, second period. 1, 2. How many shells? Determine the number of period. So second period, 17 group is fluorine, atomic number 9. Okay, I hope you got this. Now, one of the most important thing I would like to let you know, that is the valency. Okay, let us talk about valency. Group 1 has the outermost the number of electrons in the outermost orbit of group 1 elements have 1 electron, isn't it? Like we see hydrogen. Hydrogen, atomic number 1, has 1 electron in the outermost orbit. Lithium, atomic number 3, 2, 1 electron. Let's check out sodium, atomic number 11, 2, 8, 10, 1. So all the elements contain 1 electron in the outermost orbit. So the valency of this alkali metals is +1. Valency is +1. Valency of alkali earth metals is +1. Why +1? Because it wants to lose its outermost electron. Okay, it wants to lose its outermost electron and gain 1 positive charge. Okay, after losing 1 electron, it attains 1 positive charge. So similarly, you must understand this also. Elements of group B, like beryllium, has atomic number 4, isn't it? 2, 2. Beryllium. Magnesium has atomic number 12. So 2, 8, 10, 2 is 12. Similarly, calcium, atomic number 20, isn't it? 2, 8, 10, 8, 18, 2. So the number of electrons in the outermost orbit is 2. That means these metals are called alkaline earth metals, and these elements wants to lose 2 electrons and gain 2 positive charges. So the valency of these elements are +2. Okay, the valency of these elements are +2 because it wants to lose 2 electrons. Now let's talk about group 15. Group 15, we have nitrogen, atomic number 7, means 2, 5, isn't it? So nitrogen wants to gain 3 electrons. 5 plus 3 is 8, isn't it, to become stable. So the valency of nitrogen is -3. Okay, valency is -3. And oxygen, group 16, if I talk about oxygen, atomic number 8, isn't it? So 2, 6 is 8. Now oxygen wants to gain 2 electrons to make the outermost orbit 8, isn't it? 6 plus 2 becomes 8. So after gaining 2 electrons, it attains the stable inert gas configuration 8. That is helium, neon, argon. Neon contains 8 electrons. 2, 8 is 10, isn't it? So oxygen wants 2 electrons to make the inert gas configuration. So oxygen needs 2 electrons. So the valency of oxygen is -2. Okay, are you getting me? Oxygen doesn't lose 6 electrons to make the helium gas configuration, that is 2. Oxygen wants to gain extra 2 electrons. So after gaining extra 2 electrons, it will acquire negative charge, isn't it? So the valency of oxygen is -2. Are you getting me? Yes. Now Let us talk about group 17. Group 17, we have fluorine, atomic number 9, isn't it? Atomic number 9 means 2, 7. So fluorine wants to gain 1 electron to become stable, to make its outermost orbit stable, isn't it? 7 plus 1 becomes 8, and 8 is the configuration of neon. Neon has 10, so 10 is 2, 8, isn't it? So to attain the stable inert gas configuration, fluorine wants 1 electron, so the valency of fluorine is -1. Okay, so fluorine is the most electronegative element. Okay, now the question comes, write the formula of the oxide of group 1 element, it's a group 1, 2 and 13. Okay, 13 elements. Okay, now write the formula of the oxide of group 1, 2 and 13 elements. This is the favorite question that comes in the board examination. So oxide of group 1, let's take potassium. Okay, let's take potassium. The outermost orbit has 1 electron, isn't it? The outermost orbit of potassium has 1 electron. We have seen that 19, the atomic number of potassium is 19, means 2, 8, 8, 1, isn't it? 2, 8, 10, 10, 8, 18, 1 is 19. So the outermost orbit has 1 electron, so it wants to lose 1 electron. That means +1. Its valency is +1. So oxygen has valency 2 negative, 2 minus, isn't it? Because the atomic number of oxygen is 8, and 8 means 2, 6, and it wants to gain 2 electrons. It wants to gain 2 electrons and become 8 in its outermost orbit, isn't it? So now the formula of the oxide will be, this 2 will come down, cross multiply 2, and 1 will go down out there, 1. This 2 will come here, this 1 will go here, K2O or K2O. Okay, this is just an example, K2O. You have to write in the exam X2O. X2O means any element from group 1. Okay, now from group 2 we have valency 2 positive, isn't it? 2 positive, and oxygen is 2 negative. Now 2 positive, 2 negative cancels out, so the formula of oxide becomes XO. Okay, 2 positive and 2 negative cancels out, and formula of oxide becomes XO. Or you can write MgO. You have seen the formula like this, MgO CaO, isn't it? This magnesium oxide, this is calcium oxide. Okay, now for formula of oxide from group 13. Okay, let's check out. 13 means atomic number 13 means group 13 means group 13 means atomic number, let's check out of 5 or 13. Okay, atomic number 5 means 5, that is boron, means 2, 3, isn't it? And 13, aluminum 13, 2, 8, 3. The outermost orbit has 3 electrons, and it wants to lose these 3 electrons and become stable, isn't it? So after losing these 3 electrons from the outermost orbit, this becomes positive, so it has X3 plus. Okay, valency of group 13 element is 3 plus, and oxygen has 2 minus, isn't it? Valency 2, 6 means it needs 2 electrons. So the formula of oxide will be X, this 2 comes down here, and this 3 goes down there, X2O3. Okay, X2O3 means any element from group 13. X is the any element from group 13. I hope you got this. Now, let me give you some information. From this periodic table, group 1, 2, 13, 14, 15, 16, 17 are called representative elements. Okay, elements. If somebody asks you, then you should say, what are representative elements? Means group 1, 2, 13, 14, 15, 16, 17 are called representative elements. Group 3, 4, from here 3 to 12. Okay, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 are called transition elements. Transition elements. Okay, and group 18 are called inert element. Okay, they are called inert because they do not react with any other elements. Inert elements. Please remember this. Group 1, 2, 13, 14, 15, 16, 17 are called representative elements. Group 3, 4, 5, 6, 7, 8 up to 12 are called transition elements. Group 18 called inert elements. Okay, now elements of F block are called inner transition elements. Inner transition elements. Elements of F block are called inner transition elements. Okay, check the variation down a group. Okay, atomic volume, ionization energy, electron affinity, metallic character, and electronegativity. Down a group means when you move down a group. Okay, atomic volume. Atomic volume means the atomic radius, isn't it? You can say atomic radius also. Let us draw the atomic structure of hydrogen. Atomic number is 1, means 1 proton within the nucleus. That means 1 electron should be outside the nucleus, isn't it, to become neutral atom. So atomic number of lithium is 3, means 3 protons within the nucleus. That means 3 electrons should be outside the nucleus to become this atom a neutral, isn't it? 2 electrons in the first orbit and 1 electron in the second orbit. Now comes atomic number 11, sodium. 11 proton within the nucleus, 2 electron in the first orbit, 8 electron in the second orbit, 2, 3, 4, 5, 6, 7, 8, and 1 electron in the third orbit, first, second, third orbit. Okay, now as you go downward, you see that atomic radius is gradually increasing, isn't it, with the number of shells being increased. First shell only, 2 shells, 3 shells. So as you move down a group, the atomic radius increases, which means the atomic volume increases. The atomic volume increases as you move down the group. Atomic volume increases. Atomic volume increases as we move down a group. Okay, I hope you got this. Now let's check out ionization energy. What is ionization energy? Ionization energy means energy required to detach. Detach means to remove. Okay, to detach the outermost electron, to detach the electron from the outermost orbit, to detach the electron or electrons, sometimes more than one, isn't it, from outermost orbit. Okay, outermost orbit. Energy required to detach the electrons from outermost orbit is called ionization energy. Okay, here this electron is very close to proton, and you know that protons are positively charged and electrons are negatively charged. So there is always a force of attraction between the two opposite charges, isn't it? The force of attraction between positive charge and negative charge. So this electron is close to the proton, isn't it? So that means this proton holds this electron with strong energy. Force of attraction between this proton and this electron is very much high. So energy required to detach electron from this orbit is very high. So ionization energy is very high. Now if you move to this atom, this electron in the outermost orbit is a little far away from this proton, from the nucleus. So energy required to detach electron from this orbit is a little lesser, isn't it? So in this atomic structure, you see this electron is very far away from this proton, isn't it? So the force of attraction between proton and these electrons are much weaker and compared to these two, isn't it? The force of attraction between this proton and this electron is much weaker than the force of attraction between this proton and this electron. So the energy required to detach the electron or to remove the electron from the outermost orbit of this atom is much lesser in this case. So ionization energy decreases down a group. Okay? Decreases. More you move downwards, the more less energy you require to detach electron. Okay? Are you getting me? More you move downward, the more lesser energy. The more lesser energy means the lesser energy you require. Okay? If you move down a group, lesser energy will be required to remove the electron from the outermost orbit. Okay? I hope you got this. Now comes the third term, electron affinity. Electron affinity is nothing but tendency to gain electron. Okay? You can say energy released by atom while gaining electron. When we detach electron from an atom, we need to put extra energy, and that energy is called ionization energy. Okay? When you want to detach electron, means when you want to remove electron from the outermost orbit, then at that time you need to put extra energy to remove the electron, and that energy is called ionization energy. But if you add extra electron to any atom, some amount of energy will be released, okay, and that energy is called electron affinity. Okay, so when you put electron here, very great amount of energy will be released because proton is very close to its outermost orbit. Here less energy will be released because proton is little far away from the outermost orbit. Here the proton is very far away from this orbit, isn't it? So very less amount of energy will be released. So as you move down the group, the energy released will also be less. So that means energy release will be decreases. Electron affinity will decreases down the group. Electron affinity will decreases down the group. Okay, down, if you move down the group, electron affinity will decrease. That means when you put some extra electron, the amount of energy that will be released will be lesser and lesser as you move down the group. Now comes the metallic character. Metallic character is nothing but the same thing. When you metallic character means the atom which loses its outermost electron easily are called the best metals. Okay, now if you see here, this atom do not want to lose this electron because the force of attraction between this proton and electron is very much high, because this proton and electrons are very close to each other, isn't it? Here this electron cannot be easily removed because the force of attraction between proton and electron is very high here also. But in this case, the force of attraction between proton and electron is much lesser as compared to these two atoms, because proton is far away from this electron, isn't it? So this electron can easily be removed. So when electron can easily be removed, then that means metallic character is very high as you move downward. Okay, metallic character means tendency to lose electron. Metallic character means tendency to lose electron. Okay, tendency to lose electron. Tendency to lose electron. The atoms which lose electrons very easily are called good metals. So metallic character increases as you move downward. Metallic character increases. INCREASES, increases. Okay, metallic character increases as you move downward. Now electronegativity. Electronegativity means non-metallic character. Electronegativity is nothing but non-metallic character. Non-metallic character, metallic character increases means non-metallic character decreases, isn't it? Metallic character increases means non-metallic character decreases. Electronegativity means non-metallic character. Okay, electronegativity means non-metallic character. So metallic character increases as you move downward means electronegativity decreases as you move down the group. Okay, now we have seen variation down the group. Now let's check about variation across a period. Atomic volume, ionization energy and metallic character. For example, let's take period 3. Elements of period 3: sodium, atomic number 11, isn't it? Sodium, atomic number 11. Electronic configuration is 2, 8, 10, 10, 1 is 11. Magnesium, atomic number 12, isn't it? 2, 8, 10, 10, 2 is 12. And now comes aluminium. Aluminium, atomic number 13. 2, 8, 10, 10, 3, 13. Now comes silicon, atomic number 14. 2, 8, 10, 10, 4, 14. Phosphorus, atomic number 15. 2, 8, 10, 10, 5, 15. Sulfur, atomic number 16. 2, 8, 10, 10, 6, 16. Chlorine, atomic number 17. 2, 8, 10, 10, 7. Okay. Now atomic volume, actually it looks like same, isn't it? Because number of cells are same. Because in the first cell sodium 11 proton, isn't it? So first 2 electrons and then 8, 1, 2, 3, 4, 5, 6, 7, 8, then 1, 11. Similarly, if you draw this also 2, 8, 2. First 2, then 8, then 2, isn't it? Atomic volume seems similar, isn't it? Atomic volume seems doesn't change. Atomic volume seems same because number of cells in a period is same. 3 cells, 3 cells, 3 cells, 3 cells, 3 cells, 3 cells, and 3 cells, isn't it? Now, but what we see is here the number of protons is 11. Here the number of protons is 12, isn't it? Number of protons is 11, number of protons is 12, number of protons is 13, number of protons is 14, proton 15, proton 16, proton 17. Atomic number means the number of protons, isn't it? As you move from left to the right towards across a period, as you move from left towards right across a period, the number of protons increases, isn't it? Number of protons 11, 12, 13, 14, 15, 16, 17. As the number of protons increases, the force of attraction between protons and electrons increases. Okay, more protons apply more attractive force, isn't it? So as you move from left to the right, there will be more force of attraction between protons and electrons. As a result, the atom will shrink in size. The atom will shrink in size. So atomic volume decreases. Okay, decreases as you move from left to right, left to right, left to right. Okay, as you move from left to right, atomic volume decreases because when you move from left to right, the number of protons increases, and with the increase of number of protons, more attractive force will be applied to the electrons, and with the more attractive force, the electrons will come closer to the nucleus and the atomic volume will shrink. Okay, atomic volume will reduce. That means atomic volume decreases or atomic radius decreases. In some cases you will find atomic radius, in some cases you will find atomic volume, the same thing. Okay, now the second one is ionization energy. Ionization energy is the energy that is required to detach electron from the outermost orbit, isn't it? So as you move from left towards the right, with the more number of protons, more attractive force will be applied, isn't it? Here we have 11 protons, here we have 12 protons, 13 protons, 14, 15, 16, 17 protons, isn't it? Chlorine, 17 protons, isn't it? So as you move from left towards the right, the number of protons increases, means more force of attraction will be applied to the electrons by the protons, isn't it? So to remove electron from the outermost orbit, more energy will be required. Okay, so ionization energy increases from left to right, from left to right. Okay, more energy will be required. Metallic character means to lose electron, isn't it? If an atom loses electron easily, that is a very good metal. If an atom does not want to lose electron, that means that is not a good metal, isn't it? I already said you. Here in this case, it can lose this electron from the outermost orbit more easily because there are 11 protons. 11 protons applies less attractive force than 12 protons. So here these 2 electrons cannot be removed as easily as you can remove this electron. Here this electron cannot be removed as easily as this in this case. So as you move from left to right, metallic character decreases. Metallic character decreases. D-E-C-R-E-A-S-E-S, decreases. That means non-metallic character increases. Okay. Now, I hope you understood. Now, let me ask you one question. The most electronegative element. The most electronegative element is dash. Which is the most electronegative element? The most electronegative element should, as you move from left towards right, metallic character decreases and non-metallic character increases, isn't it? As you move from left to right, metallic character decreases, means non-metallic character increases. That means as you move from left to right, non-metallic character increases. And when you move from top to bottom, we have seen metallic character increases, non-metallic character decreases, means non-metal should be in the top one, in the top place. And if you move downward, metallic character increases, non-metallic character decreases. If you move from left to right, metallic character decreases, non-metallic character increases. So the most electronegative element will be fluorine. Okay, fluorine, because fluorine is here, so it is on the farthest side of this period, because this is a zero valent element. This is a zero valent element. They do not react with any other element. They have stable electronic configuration. So fluorine is the farthest element in this period. So fluorine is the most electronegative along the period wise. From the group wise, when you move from top to bottom, metallic character increases, means non-metallic character decreases. So fluorine is the most electronegative element.